fine gentlemen, and the talk is called Discovering Dark Matter Towards Better Android Malware Heuristics. I'm drunk. Don't mind me. Give all three wonderful speakers a big round of applause.
So just download this as a PDF or what?
Yeah, download.
Slides would be nice. Hit the present button up there.
Yeah.
And plug in VGA.
No, export.
No.
One of us, you should do it. One of us can log into something.
It's a PDF.
Cloud,
Okay.
right? It was Cloud, right? Cloud failed us about 15 minutes.
Did you put it on the disk?
Yeah, it's on.
All right. Switch it out and we're good. Last step. Just let him do it. It's his. That's a little. That's good. All right. All right. Plug that in. Plug in. That was to build up the suspense. So now we'll try not to mess it up further. So as we were introduced, this is Discovering Dark Matter Towards Better Android Malware Heuristics. We're three security researchers that are taking some slightly different tacks to approach the problem of Android malware. So we're going to split this up into three different segments. It's myself, Jimmy Shaw, and Matt McDevitt. So I'm going to begin here. My name is David Shaw. I'm the Senior Director of Engineering at a small computer security company called Redspin. My personal specialties are application security assessments, as well as traditional network security, internal and external pen tests, that type of thing. My claim to fame, I guess, is I was the technical editor of the Nmap 6 Network Exploration and Security Auditing Cookbook, which is kind of a mouthful to say, but is a pretty good book if you want to learn about the Nmap scripting engine, things like that. And I tweet at dshaw_, and I have no friends on the internet, so you should talk to me there. But I think it's equally as important to talk about the things I'm not.
Talk to the mic.
Sure. Is this better? But I think that for the purpose of this talk, it's equally as important to talk about the things I'm not. I'm not a professional malware researcher. I'm not a reverse engineer. I'm not an Android expert. I have an iPhone, and thankfully I'm not a Java developer either. All right. I don't know how to really. I'm not gonna pick it up. I'll just do this. Better? All right. We're having every technical problem we really can for this talk. So,
Isn't there a wireless mic?
What?
a wireless mic.
Yeah.
Anyway, we're going to break this talk down into a couple different parts. We're going to define the problem of mobile malware because it's a lot different than conventional malware, including the needle in the haystack problem, which is that there's just so many apps out there. It's really difficult to figure out which ones we want to focus on for manual analysis. We're going to go through some runtime analysis. Again, I'm a network guy, so I'm going to base that on the network side of things, as well as some network-based static code analysis. And then we'll turn it over to Matt, who will talk about DEX, going in real deep there, as well as Jimmy talking about automation, as well as the heuristics that we've determined based on this research. So part one is defining the problem. There's going to be a big block of text, and I promise I won't keep doing that. But we're going to define a malicious app as any software that either through the abuse of granted permissions or via traditional exploitation conducts activity that may be considered malicious or mishandled, which basically means that if someone's coding an app that's misusing your data or is even just poorly coded, that's considered malicious. Basically, we're saying permission abuse or traditional exploitation or security misconfiguration yields something we're going to call a malicious app. So for example, let's say you have an application that reads through your address book, your contacts list. It uploads your contacts in a non-secured way to a remote server where it's storing it in plain text there. And it starts sending text messages to all your contacts in order to propagate itself. It says, hey, we have something for you. Look at these cool pictures, something like that. What would you consider that malware? Traditionally, we definitely would. This is almost exactly what the Melissa virus did a long time ago. That's malware. But it's a little bit different if you have 10 million users. Path is a social network. We know it's iPhone, but we chose it because it was in the news like 2 weeks ago, because it did just that. It uploaded your contacts, it started spamming all of your friends saying, hey, I have photos to share with you, download this app, and propagated itself to pretty much double its users. And people got really upset about that. Now, this isn't a traditional malware application, obviously, it's a social network, but, sorry? But it's doing things that it shouldn't be. And the reason it can do that is because it's abusing permissions that you've actually granted it. So we have a screenshot of an application on Android that basically has access to all of these things, your personal information, services that cost you money. In this case, it can actually send a text message to like a paid premium provider. Yeah.
Hang on. Have you actually read the EULA? You sure it doesn't say in there we're going to send it to a person on your contact?
I don't know what people will click yes, and that's
I accept.
exactly, and that's the problem with permissions abuse in general, is that users love to say, oh yeah, sure, whatever, you can do that. It's the same thing when, like, you know, a general user has a web browser and an SSL error pops up. They go, okay, well, whatever, continue, yeah, that's fine. You know, because they're saying, look, you can access your GPS location, you can perform services that cost you money, you can review your phone log and your phone state. You know, that's something that traditionally you'd have to actually exploit something to get. But it's a lot different if you can just ask for it and the user says, oh, yeah, okay, that seems fine. So here's the problem. A lot of applications request a lot of different permissions, and many of them don't even use those permissions. So we actually have to figure out, how do we take a very large list of Android apps, because there's almost 1 million on the Google Play Store today, and figure out which ones we want to actually spend time analyzing. We obviously can't do them all. So to get into that, we're going to talk about the structure of an APK, which, you know, for the purposes of this talk, is basically just a zip file. It's easy to manipulate, it's easy to read it, you can just play around with it, and in particular, the Android manifest.xml file, which is basically just an XML file that's telling Android OS, okay, this is what the application's doing, these are the permissions that it's going to ask for, this is what it's called, what its intents are. Particularly, like I said, the manifest.permission lines. That's saying what the app is going to ask for when you install it. It goes, hey, can I do this, this, and this? So we're going to focus on that, particularly permissions that allow data read-write access on the phone, system logs, text messages, data at rest on the phone, and network read-write access, data in transit can actually take something that you've given it access to and send it off somewhere. So this is a big block of text, and we're going to put this up on a text file later. Basically, we're going to call these suspicious permissions or sensitive permissions. Read logs, read contacts, you know, access your camera, install packages. There's a big list, but for the purpose of this talk, we narrowed it down to 6. Read contacts, call phone, install packages, write and then send an SMS, and internet. You know, they're pretty self-explanatory what they're doing, but they're obviously very sensitive. So we're going to throw that in, let's just say perms.txt.
Why are you concerned about write SMS instead of just send?
Well, write SMS can compose it, and then you might hit send on it.
Oh,
So
user.
send sort of supersedes write.
Got it.
Yeah. So we have a large list of APKs, and we have some DEX files in there too that we're going to conduct analysis on. And we need to parse the data out of Android manifest.xml. Fortunately, using free and open source tools as well as some really light shell scripting, it's really easy to sort of automate that. So APK tool, freely available, cross-platform Android analysis tool. Really easy to use because pretty much all we're using it for is to decompile these APKs or unzip them. It's not super complicated, but APK tool is pretty cool in general. So we just have a for loop. We say for each element in our samples APK directory, you know, run apktool.jar to decompile it, and we end up with this large directory structure with the app name, and it's the full directory of each of those apps. So then we say, okay, well, for each line in perms.txt, which is those 6 sensitive permissions that we talked about before, we're going to use grep to basically say which of these have one or more. You might want to add on something like you know, unique and sort to figure out which ones have the most sensitive permissions that they're asking for. And just as a note, all of the random like shell lines, we're going to throw that on like a GitHub afterwards. And the reason behind this is that you can't abuse permissions that aren't granted, and you can't be granted permissions if you're not asking for them at some point. So we take this large list of potentially abusive apps, we run these for loops on them basically, and then we get a short list of apps that we're going to inspect more closely, which obviously saves us a lot of time. Before we were looking at, you know, going through this and figuring out which sensitive permissions are there, we were doing that manually, and that was a huge pain, so I don't recommend it. So now we have a short list of apps. So what do we do once we have apps that say, hey, these people they can send text, they have internet access, they can read your contacts, and generally a lot of it is context dependent. If you have an application that's a contact manager, it makes sense for it to have access to your contacts. If you have an application that's you know, a camera app, why does it need your contacts other than everything is sort of a social network these days? So it is context dependent, but it saves a lot of time. So once we have that list, we can go into actual runtime analysis. And this is where it gets a little bit more fun. Android comes with an emulator, which is designed so that developers can test their apps without having to own an Android device or put it on hardware. It's really easy to set up. You just do Android create AVD with the name of test, type Android 17. And we don't actually need to do man in the middle to start out when we do this analysis, because Android has a really handy flag that can basically take all of the network traffic and dump it to a file. So basically the methodology is run the emulator, install the APK, capture the packets, and then perform analysis on that later. So the analysis, again, really easy. Android, you run it with the TCP dump flag, very handy. Output.pcap, you install the application using ADB install Instagram 106. And you want to use the app normally, just clicking around in the emulator for more than 5 minutes. And the reasoning behind that is that Google Bouncer will test an app for 5 minutes to see if it's doing anything bad. That's how you get approved for the Google Play Store, which is great, except the problem there is that once people realize that, they just wrote in timers so that it doesn't do anything bad for more than 5 minutes. So, if it's going to call a CNC server out in like Russia or something, it'll do that after 5 minutes. And then you have this PCAP. Once you have the PCAP, you can actually use traditional tools such as TCP dump. So basically, you can read the PCAP, and you want to say that the source net is from the Android, originating from the Android, but not going to the Android, because we don't really care about that internal traffic. We're going to print the fifth column, which is the remote destination as well as the protocol, and sort it unique, so we can see in that time that we were just using the app and just clicking around, what was it connecting to? Was it doing anything that looked shady just right off the bat? So with this, again, Instagram, it was like, okay, well, it's connecting to some EC2 servers, pretty standard, a bunch of Google servers, an NTP server, which is a little weird, and a CloudFront, probably load balancer. So nothing that jumps out at us as, oh, that's probably something malicious. But we do run into a problem, which is if you throw some regex on there to basically see a count of protocols that's being used, we end up seeing 13 HTTP requests, 532 HTTPS requests, and 1 NTP request. And if you're looking at it, okay, well, we have a packet dump, the problem sort of jumps right out at you, which is that almost all of that is just SSL wrapped HTTP requests. And crypto, as great as it is, obviously work both ways. When the wireless here is working, I can't, read your email, but also we can't see what this application is sending to and from potentially untrusted servers. Is it using that data that it may have access to? The problem is that Android doesn't make that easy for us. It's not, they could make it where, oh, it'll just print out those plain text packets. It doesn't do that, I guess for obvious reasons. So the TCP dump flag is no longer really super relevant there. And installing a CA, which we will get into in a few minutes, isn't really what you want to do if you're just in the middle of going through a whole list of Android apps. It's infeasible for quick analysis. Fortunately, we can use a tool called Android Proxy to basically do DNS redirection combined with an intercepting proxy to read those in plain text. So Android Proxy is just an easy Python tool, works on all, it's cross-platform, only requires twisted, and basically uses DNS trickery to do that. In the way that, for example, your emulator requests, hey, what's google.com's IP? Android Proxy will assign it something and keep track of it, 1.1.1.3. Then the emulator will then try to connect to that IP address, and our intercepting proxy will do the rest of the work. So you run that with the HTTP proxy flag and point the DNS server to localhost. So here I am in my emulator searching for ponies because little horses are great. And Android proxy is on the back end doing its thing. Here you can see that I went to encrypted.google.com. It rewrote that to 1.1.1.6, and then it can basically keep track of those connect requests. Which allows me in Burp Suite to say, oh, okay, well, here's this plain text encrypted stuff. The problem is that it pops up these warnings, and it says, hey, something's going on. This can happen if there's certificate pinning. It can happen if there's just something that goes weird in Android proxy, and it basically says, this actually wasn't the certificate that we were expecting. And again, that's the same problem that we've had with web browsers. If you're doing analysis and this pops up, it's actually totally fine. If you can just click continue, it doesn't matter because you're still going to be able to see that traffic. The problem occurs when it's saying, okay, well, what if it's not something happening on the front end? What if it's making some SSL connection on the back end and it doesn't give you the chance to click forward? Because as an analyst, you can actually just move right past it. That becomes a little bit more difficult, and for that we actually do have to install our own CA, in this case the PortSwigger CA from Burp Suite. So Android comes with Make SD Card, which is a nice little tool to create an SD card image. You run that with the -SD card flag, super simple. push on the cert, and you can install this manually via the security settings, which persist post reboot. You don't always need to have the SD card flag mounted every single time. It doesn't need to be there physically, or virtually, I guess. And then you can use a direct HTTP proxy to your intercepting proxy, in this case, and it basically allows you to see anything. The problem is that it is a user install credential, so we don't see certs that are, we don't see malware that's basically making a distinction between a system CA and a user installed CA, but we're thinking that we probably will in the near future. It becomes a problem with certificate pinning.
Definitely.
Yeah. So now you've seen, okay, you can run an app, you can see where it's connecting, you can click around, you can say, is this doing anything weird? What are we going to do with it? The problem is that it doesn't always happen right off the bat. It's not something that can always be detected. For example, if you have an application that, let's say, on the 1st of every month, it'll connect to a CNC server and download a new config file, because we've seen that. If that's not when you happen to be doing your testing, you're going to be sort of out of luck. So that's when we get into some light code analysis. Again, I'm focusing on the network part, and then Matt will get into a little bit more detail after that. So we'll look at a DEX file, a Dalvik executable that runs in the Dalvik virtual machine on Android. It's really easily convertible to the Java jar format because it's all written in Java anyway. And we can use open source tools like dex to jar to basically just take that DEX file and spit out a jar file, because there's a much bigger tool set that we can actually work with if it's as a jar file. So then we use something like JD GUI to decompile that. We just open it up, save all the sources, and then it saves as a zip file. We unzip that, and then we have a source directory. So from here, we can go ahead and search for remote hosts that might be hard-coded. Now, if there's some obfuscation there, if they're trying to hide it, it won't work. But generally, malware authors tend to be lazy. They're lazy, and then if that doesn't work, they increase their complexity. So generally, we'll see a hard-coded host. In this case, as you can see, it's a grep regular expression that's looking for 4 dots in a row, or HTTP or HTTPS in the source directory. So in this particular sample, which was just downloaded from malware.lu, we got a bunch of copy9.com hosts, which is, first of all, the file names themselves are a little bit sensitive. Login receiver and auto-run receiver don't sound like they're really doing a lot of good things. But this can feasibly locate hard-coded hosts. Like if it is checking some random web server in Russia the 1st of every month, we'll generally be able to see that. The problem is that to get to this point, like I said, you have to run Java JD GUI, which is really kind of a pain. We want more automation wherever we can. So we're still working on that. But from here, you say, okay, well now we have the whole source directory. We can actually look at Java and Android docs to actually see if there's anything that we want to look for. So for example, the content URI :// SMS inbox sounds like, okay, well that's how you read the inbox. It says that in documentation. So we can go from here and look for anything with the content URI. And in this particular piece of malware, we see, okay, URI parse, that content URI of the inbox. So okay, we know that it, not only has it requested that permission, it's actually doing something with it. Because we tend to see apps will request everything they think they can get, even if they aren't going to use it. And it's a big problem with false positives because we don't want to get caught up in that. So now we say, okay, not only is it requesting this permission, it's actually doing something with it. So, for example, if you add on the tax C10, you'll probably see full method. It gives the context with grep. And it works with a lot of different things. The whole SMS URI, phone, socket for creating new network connections. So what we actually found with this particular piece of malware is that it was SMS Manager was the winner there. Basically, we found a method which was send data of SMS to website to whack logs, log SMS post.aspx. It's basically taking all of your text messages that you're receiving or sending and then shooting that off to, it's actually copy9.com, to that receiver, and it stores it. And this is actually designed so that people can spy on their spouses, things like that. So, this is the cursory top-level view of static code analysis for Android, which leads directly into lower-level utilities such as, source code and Dalvik bytecode review. And again, all of those commands are going to be on a GitHub. Basically, the idea and what we're aiming for is that if you take that tool set as well as all those commands, you can take a whole bunch of APKs and perform some analysis yourself, because there aren't really enough people working on it right now. So Matt?
Hey guys, I'm here today to talk to you about some hardcore DEX. Basically, we're gonna be looking into a little bit of DEX. And first and foremost, I'm going to talk to you about the who I am. I'm Matt McDevitt. I'm a mobile security researcher for McAfee. I do mobile malware analysis, engineering, and malware detection. I also do a lot of x86 stuff. x86 is mostly my background, and embedded system analysis. So a wide range of stuff. And basically the difference, there's not many differences between x86 malware and mobile malware. It's pretty much out to do the same stuff. It's out to get your contacts. It's out to get your docs. And it's out to make money. That's why these people do this. So let's talk about the DEX file format. As you can see, it's pretty much, if any of you are familiar with Java, it's pretty much the same thing we're looking at with Java file format. We have the header. We have string IDs, we have methods, we have string data, we have all different types of stuff. The most important stuff we're going to be looking at here are methods. Okay, so when you're actually looking at the DEX file, when you're looking at the methods, that is going to tell you what the objects are that are actually pointing into the VM and how the strings are being built, what's being built. We're going to get more into that in a bit. Reading Dalvik. Okay, so here we have the package name. Okay, that's the Java package that was used. Object name, and of course the method. As you can see here, there are 3 I's next to method name. That's the attributes of that method, how many attributes there are. And Z is return type, and Z is bool. So that's Boolean. Fields, what's a field? So a field name, it's going to return a string, or it is a string, or what have you. And it'll push that into register. Oh, by the way, difference between Java, the JVM, and Dalvik is that this is register-based, okay? And the reason it's register-based is because it is, it's optimized. It's a lot faster. It's a lot faster than going on stack-based. So here are all the return types that we're going to be looking at today. Voids, booleans, bytes, shorts, chars, okay? So that's what it's actually going to be returning back in the code, if it's a char or if it's a byte, if it's a float. Okay, I think we get the picture here. Let's jump straight into hello world. Okay, so when we're looking at Dalvik, this is what we're going to be looking at. So first, object hello world. This is hello world. Okay, the string is hello world. It's going to push it down. It's going to invoke the static method, which is make text, and then it will do v for show, and it will just return 0, done. So when you actually run this, on your Android phone, when you click the button, I didn't include any of the invoke code or anything like that, but when you click the button, it will show hello world at the bottom of your screen. Okay. I'm going super fast here because there is so much to talk about today, to be honest. Malware samples galore. Right now, seriously, on a given day, I can come across new Android malware samples, like pretty much every day. And there's quite a bit of Android malware suppositories. Yeah. There's a bunch of Android malware repositories out there. But then again, you're going to come across pieces of malware that don't work. You're going to come across things that aren't even malware, just things that are just doing a lot of ads, just things that are just annoying. All different types of things. It's all over the place because of the detection methods that we have currently. Detection methods are still really flaky. Definitely not as advanced as x86. Actually, not even near as advanced. The 2 main types of Android malware. I got into this in the beginning, but basically, generally, data stealers are interested in SMSs, contacts, phone logs, data logs, pretty much everything you can think of on the Android phone. This is what data stealers are interested in. And then all that stuff is transferred via HTTP post or JSON, okay? And then premium service abusers. Obviously, you guys ever seen those 5-digit characters you can text to, and then It says, hey, what's up? You just got charged $250. That's what this stuff does. So, and usually these are combined with each other. Exactly. So usually these are combined with each other in malware. Okay. I guess best bang for your buck. So.
That's another service.
Yeah, exactly. So so basically the stuff that I'm going to be pulling out today is stuff that was, of course, brought up from CNC services on the Android phone.
Explain them what the CNC is.
Yeah, CNC basically is command and control. So if a piece of malware is dropped onto, if a piece of malware is installed on a phone, if it's CNC, it will grab SMS text messages from that server, and those text messages will be filled with commands or filled with configuration data that's going to be used to control the malware. And basically, from then, it will execute this. Oh, no, that's the next slide. But this is some permissions, and these permissions are actually really common. You'll basically see these permissions for almost every application you install. Stuff like send and receive SMS, install packages, delete packages, read contacts, call phones. This is dangerous stuff when you really think about it. If you're saying something can install packages, you're seriously telling that application that it can grab packages from another location on the phone, whether it's on the storage device or whether it's on the device itself, and install that piece of malware. Call phone, of course, it will just start calling people in your contacts, or sending SMSs. It will just start sending SMSs to people on your contacts. So pretty basic stuff. Contact stealing.
Install all your contacts.
So basically, this is some looping code, as we can see. Move to next. We'll type. So it'll get the index of the database. It'll get those strings, and it will actually build out the contacts using string builder, which is our Java object. Of course, then it will print out using phone colon for each contact. Okay, and you can see this from looking at this piece of code for just a couple seconds of basically what it's doing. It is creating a list of those contacts, and then I actually didn't include this part, but then it actually moves the contacts into a list called phone book somewhere on the external device, which is SD card. This is the part where it sends it. Okay, I forgot to mention that these are control flow graphs. Okay, and basically what that is it tells you how the program moves, how the application actually works, where those methods are going, and then which pieces of code it's actually jumping to next in order to execute the next functions. And of course, you will have methodologies within those boxes. Okay, so here, this is the part where it sends it. It grabs from the phone book, and then we can see where it's getting the default HTTP parameters. Now, this was a two-stage malware, two-stage piece of malware. Okay, basically what that is there's one portion where it actually installs onto the phone, and then the next portion where it actually grabs the configuration, and it'll also grab contacts. It'll actually also grab SMSs from the server itself, saying, "Hey, this is what we want you to do next." Okay, so it would send something like send contacts. Unfortunately, my acquisition of this piece of malware in general, it was dead by the time I got to it. So if you get a dead piece of malware,
It's not so much fun.
it's not as much fun, because then you actually have to wind up building the malware yourself.
Meaning,
When you get that dead piece of malware, you want to figure out the entire puzzle, how this piece of malware worked. Was it connecting to the internet? Where was it connecting to on the internet? What kind of data was it looking for? And this takes a bit of fuzzing. I didn't talk about that in the presentation, but basically what fuzzing is just like sending random characters, random commands, things like that, seeing if it actually picks up on it and starts to work. If you can get that piece of malware working, you solve the puzzle, and now you have the entire piece of malware altogether. There's a lot of yeah, exactly. It's puzzle solving, and there's a lot of mistakes, and there's a lot of hair pulling, but it's super fun. I have to mention that. Yeah, exactly. It's really rewarding, really rewarding. So it gets HTTP parameters from the configuration file, which I actually did not find. And it'll have the settings, the server, and yeah, then it'll just send it using a couple different methods, and then get the response code from the server and disconnect. Done. Okay. Send SMS. Actually, forgot to mention that this is only part of the portion of the code where it's actually building the SMS. Yeah. So as we can see, just looking at this code for a couple seconds, we see stuff like IMEI, IMSI, SID inversion. That is everything about your phone. That is your universal identifier. That is everything. So how would this be useful to an attacker? This would be useful to an attacker because now they basically know who you are. Okay. There's also, and this is all in read phone state as well. You can also get GPS coordinates, all different types of stuff, and that was also in this piece of malware, but I didn't include it here because there's a lot of stuff to talk about. Okay. Make call. Okay. It's pretty obvious what this piece of code does. We have an intent. The intent is to action call. Okay. And so it's going to append the phone number. And then it parses from the list, and then it does add flags for the call, and then it starts the activity. Okay. Sure, premium service. Premium service calls. Exactly.
Repeat the question again.
No, what's the purpose?
Repeat the question so they record.
Oh, I'm sorry. He just asked, what's the purpose of making calls? And as I originally talked about, purpose of making calls is to call premium service numbers. And that could cost, that costs like $3, so.
Or maybe they just want someone to talk to.
Exactly. I mean, they're bored. I would get bored living in a basement somewhere too. Yeah, so, that's what we're looking at, okay? So that was some really basic stuff. I didn't even get into obfuscation, which is of course going to be something that's going to be more widely used. I didn't get into code injection, which is something that's currently used. But the point here is that malware is going to get more complex as time goes on. So we really need more analysts. We really need more people that are interested in this stuff to just dive in. And yeah, that's my talk. I'm going to move on to Jimmy.
All right. Yeah. Okay. Who am I? I'm Jimmy Shaw. I work in McAfee. Work with Matt. We do mobile malware analysis. If it's small in the car and has a microprocessor, it's probably something that we handle. Right. So I'm also not a Java developer any more than Matt or David are. And let's see, back to the problem. Okay, so you've just basically gotten a crash course in what it is to be a mobile malware analyst from both David and Matt's talks. It's that complicated, it can get even more complicated. The point is, if you have to actually take a look at an app and see is it good or bad, it takes a hell of a lot of time. These guys do a hell of a lot of work. We all do a lot of work, and we don't have enough people to go look into these things. The problem is we've got millions of apps, some are good, most are good. How do we find the bad ones? That's the real question. We've got all these manual techniques of doing it. If we could just automate that, it would make our job so much easier. We could spend more time looking at the really, really bad ones. Not the ones that are like, okay, it's just sort of bad, or maybe it's a social network, maybe it's a social network that takes too much information. Something worse than that. So the real rookie is, how do we automate this? We've been working on tools to basically take a look at an app, pull the information and tell you, okay, it's suspicious, send it to a real human being. Oopsie. All right, so we have, 1 second. Yeah, okay. We're looking at heuristics. Heuristics are basically rules of thumb, things that tell you something is wrong. Say you're a police officer and you're doing your rounds or you're on your beat and you see a store and the window is broken. That's a really big indicator that something's wrong and a pretty good idea that something's really bad. Also, if you say you're the same cop, you're looking at a store and say there's a trash can in front of you tipped over. That never happens. It's very odd. I mean, because you live in a very, really nice neighborhood, it's a nice store. Something could be wrong there. That tipped over trash can is pretty much a heuristic. It's a more wider net, and it'll net you more solutions. Now, if you look at other businesses that aren't, and nothing's wrong with them, you don't have a problem. In this case, you will need something to tell you what is wrong. So what we're looking at is ideas of things that'll give you a hint of that something there is wrong with a particular app you're looking at, so that you don't have to go drag out the disassemblers and the decompilers and all the other tools and then the network analysis, everything right now. First, you just want to run a tool against it and tell me, is it bad or good? So let's look at the first idea. Apps ask for a lot of permissions. Bad apps ask for a lot of permissions, a whole lot they don't even need. So yeah, that's the thing they do. Can we use that to detect them? Detect if it's a bad app or a good app? Not really. It's not really unique enough because even regular apps you've seen ask for a lot of permissions. What do you do? Well, it still might get us somewhere. There are still, if you look at David's original list of wall of text of permissions, we have maybe, let's call it an evil 20 just for argument's sake. A bunch of evil 20 bad permissions. If an APK uses those permissions, we should probably send it over to Matt or someone to go take a look at it. Like to tear it apart and see, is it bad? And of course, there is a chance of the false positive. It's not really unique enough, but it is more like, once again, the trash can that's fallen in front of the, that's tipped over in front of the business. Something could be wrong, we should take a look at it, maybe. Whoopsie. So what we have is a tool called dump AXML, which takes you feed it an APK, and it'll tell you information from the Android manifest file, Android manifest.xml file, which when it's in an APK is stored in a binary encoded file. So you would need a tool like APK tool or like dump XML to dump the human readable form. Why human readable? So we can see where it says, oh, we asked for this permission, that permission, and the other permission. We have all these permissions, but wait, since we have a tool that takes them apart, why don't we have the tool tell us what the permissions are? In this case, dump AXML, looking at this sample here with numbers on it, tell us, hey, this thing's suspicious. Why suspicious? Because we're in dump AXML, in our heuristics, we have a list about the evil 20 that David was pointing out there. Those same permissions, if you're using those permissions, we should probably take a look at it. It's no guarantee that it's bad. It's no guarantee that someone's broken into your store, but it requires a closer look. Definitely. What does this particular sample ask for? It asks for internet access. It asks for access file location, which is as opposed to access course location, which gives you the Wi-Fi and more. What's the other one?
Towers versus GPS.
So towers versus the file location, which is GPS, which gives you a pretty close exact location. And then also read contacts, so it's reading your contacts. So what does this app do? Those are all things a normal app would do. In this case, though, this is Android/PBL.A, which is a phone book leaking app. Basically, it looks at all your contacts and forwards them over the internet back to the attacker. So this gives you an idea that would have been something to look at. Of course, there are quite a lot of things to look at your phone book, so it is a high FP rate, a high chance we get clean clean applications. Another idea. Maybe we try blacklisting certificates because every APK needs to be signed. So if a bad guy's written a bunch of malware, he probably uses the same certificate, the same signing account. And when Google bans some of these apps, they basically disable that certificate. They wrote the certificate, they destroy the account, and you're good to go. I mean, they're no longer effective. On the other hand, there may have been a whole bunch of apps that were released signed by the same author, and maybe on a third-party site, maybe in an Aware site, somewhere you can get it still available. If we just took a look at the basically check some or fingerprint the certificate and detect based off a blacklist of malicious signing certificates, we can pick up a lot of things that are possibly malicious from the same malware author. It's a good idea. I mean, they'll use the same certificate. There's no guarantee, though, that they'll always use it, so there is a chance of false positives, which kind of makes our job a little more difficult, but it's still much easier, and it's reduced to the entire haystack from, say, a big giant one to maybe cut them in half. Right. Once again, it's not totally unique because you could use different certificates. The bad guy could, or it may not be. It may use some completely different accounts. On the other hand, we'll pick up quite a bit. Like say, just for example, argument's sake, Android Droid Dream used it was about 30 to a little bit over 30 apps in the Google Play Store that use the same certificate. So if we had picked up 2 or 3 of them and blacklisted those certificates and just ran it against all the samples we have, we would have picked all the rest of the 30 in much less time than it actually took. Originally, Droid Dream took a little over I think a little bit over a week for everyone to, including Google, to come in and take down the app. So something like that kind of automation like that would help us so much more. Let's see what the tool would do if we were actually doing that heuristically. Dump XML actually has a list where we can add blacklist of certificates and say, these are the bad things. So we run it against another sample. Right. Yes. We have a suspicious variant. It tells us what variants we have. So in this case, it says fake installer variant. Fake installer is.
Wrap it up, B.
All right, we're wrapping it up. I don't need ministry out here. All right. So Android fake installer. It's a Trojan that pretends to be an installer for a legitimate app. So it tells us that's what it is. Now, the better idea is to combine the two at the moment. Let's go with multiple indicators. So we've got a store that's got like a trash can tipped over and maybe something broken inside the store. That looks odd, right? Okay, so what do we do? If we take both of them, take both the badge certificates and suspicious permissions, we're more likely to see something. We're supposed to see if something's very likely. To see if something's really bad. So we added that into the tool as well. You run the heuristics flag against a particular application, the same fake install application. It tells us what? Boom. Yes, the certificate's bad. It's something we've seen before. It detects. Also, it tells the permissions are bad. All right. And it's the same kind of permissions, pretty much. But what we have in the last is we will have a tool release within a week, dump axml.pl. It provides heuristic detection, and it'll allow you to tell you what permissions are in your APK. So you can use this and pretty much do everything we've done and pretty much have something you can say, give it off to Matt or give it to David and say, tell me, is this bad? It looks pretty damn suspicious. We have a tool. It'll be available by the end of the week, and we're good to go. Are there any questions? Okay. Question in the audience.
Did you have better prepared for your talk so you can start on time?
Yes, so the question is, should we have better for a talk so we can start on time? Apparently there's an issue with Wi-Fi networks that don't like to work with you when they're connected on multiple laptops and devices, but yeah.
Can we keep that signed
Yes.
for the last talk?
For those of us who don't know anything about Android apps, where do you download Android apps so you can run them against that?
All over the place. Where can you download apps running into scanner?
Google
Everywhere.
third-party App Store. They're just places that you can just download them.
You can
All
just-
sorts
you
of
can
places.
download them. Yeah.
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 Or if
Of course, you want the malware samples. There are also places that do that.
download like malware.com.
Yeah.
There are usually downloads.
Is there a Q&A session? Or we gotta go. Okay, we're good.
Q&A outside.
Got it.
Sorry, boys.
No, thank you very much.
So should I give this out now that I'm okay here?
You take too long, I'm gonna flash.
Okay. So don't go anywhere. We're gonna grab the people in the HHV and the lockpicking village, and we'll do closing ceremonies right here in 2 to 3 minutes.
Nobody go nowhere. Good runs.
And before I go, just remember this is your last chance to buy LayerOne t-shirts. So go right now and buy them in bulk. In bulk. Wholesale.
We have both discounts.
Also, ASG, one of our vendors, is running a raffle. If you have any last-minute entries into the raffle, you need to go outside and talk to Guy right now.
He moved. I saw him.
Yeah, well, we lost over because we were short on time. So not being able to start. I'm not worried about that. They asked me to talk. I was never do that. A lot to learn.